As promised in previous video, now we will discuss about causes of the problems in current SI units for rotational quantities. These are some problems identified in the second video of this series. It leads inevitably to ghostly appearances and disappearances of the radian in the dimensional analysis of physical equations. A perennial problem in the teaching of mechanics, where radian appears on one side of an equation, but not on the other side. The typical advice of ignoring radians during dimensional analysis and adding or removing radians in units according to convention and contextual knowledge is pedagogically unsatisfying. Inflexibility of conversion between radian and other units of angle in some equations, which will be explained further later. This table from third video shows where the current SI inconsistently treats radian, highlighted with yellow background. Note that both tangential and angular quantities describe the same rotational system, only viewed from different perspectives. Inconsistent nomenclature like torque and moment of inertia may contribute to hide their roles as the angular version of force and inertia, respectively. We have identified some causes of the problems. The first is that radian is treated as dimensionless in SI. As the result, physicists became accustomed to hiding the radian instead of questioning whether the choice was physically meaningful in dynamics. Taylor expansion series of trigonometry, exponential and logarithmic functions require the argument to be unitless, not merely dimensionless. Just because the numerical value is 1 doesn't mean that the conversion factor doesn't exist. The second identified cause is educational inertia. Many learners assume the system is already perfect because it's how they were first taught. The third cause is cognitive bias toward simplicity over rigor. Simpler heuristics like radians don't matter become default because existing unit conventions worked well enough, even though they cause confusion later. The fourth cause is equations still work numerically. Without explicit failure in calculations, there was little practical incentive to challenge the unit conventions. In physics, a unit can be removed from the calculation without changing the numerical value of the results if the physical setup is arranged to keep its value to be 1 numerically. Rigid lever and fulcrum created an illusion that rotational radius is constantly equal to geometric radius, thus radian can be removed from unit for torque. The fifth cause is lack of distinction between static and dynamic concepts. The semantic ambiguity prevented clear categorization of concepts that behave differently. It led to ambiguities in unit assignments and obscured the role of radians. Geometrically, two foci of an ellipse are identical and indistinguishable, hiding the fact that the sun, active focus, and the empty focus are dynamically distinct. The sixth cause is institutional momentum of SI standards. Even strong theoretical proposals face institutional inertia. The seventh cause is historical path dependence. The subtleties of rotational quantities took time to unravel, delaying the need for a fully consistent unit system. Inconsistencies were patched rather than systematically corrected. The eighth cause is subtlety of angular units. Unlike meters, kilograms, or seconds, the radian is an angular unit defined by a ratio, making its dimensional nature less obvious. Let's be more consistent with the use of angular displacement. It's only applicable for rotational system, or its projection in some way. While a frequency in non-rotational system doesn't have displacement angle in it, like how often water drips from a leaking faucet. Thus, the standard unit for general frequency is Hertz, or 1 per second, while the standard unit for angular frequency is radian per second. The ninth cause is lack of a holistic review of rotational units. While individual issues, torque energy conflicts, moment of inertia inconsistencies, were noted, no one unified them into a single, systematic correction. Our insight breaks the deadlock by introducing a small but powerful conceptual change. recognizing rotational radius as a distinct quantity from geometric radius and keeping radians explicit. This is a rare case where a clearer model was not discovered earlier, not because it's too complex, but because the existing system appeared to work well enough and discouraged deeper inspection. The distinction from geometric radius is most obvious when the system dynamics causes change of rotational radius. This involves radial motion which doesn't exist in a purely circular trajectory. It can be seen in non-circular motions, like elliptical orbit and spiral motion, which will be described in the next video.